Now here we are at our first weekly SAT question, which reads, in the xy plane, the graph of the equation y equals negative x squared plus 9x minus 100 intersects the line y equals c at exactly 1 point. What is the value of c? And then, of course, we have our usual 4 answer choices. Before we dive into the solution for this question, let's take a look at your results. So from this pie chart, you can see the majority of answers were split between two responses, and that's C, that's the orange there at 55.4%, and that kind of burnt orange looking red at 40.2% at answer choice B. There were a handful of answers of A and D. Now, of course, there can be only one answer, and I wonder which one it is. So, interestingly, if you take a look at the next bar chart here, you'll see that the majority of us thought that this was a fairly easy question when rating the difficulty. You can see 38 of the 92 responses, that's about 41%-ish, thought it was an easy question. And if I scroll over here, you can see that only 9 people, less than 10%, thought it was a hard question. Here's what I find very interesting about this. Of the 38 people who thought that this was an easy question, 22 of those were incorrect. So you have to realize that College Board has been at this for quite a long time, and they know how to make a deceptively simple question, of which this turns out to be one. Okay, so let's actually get to the solution, shall we? Now I'm going to take this opportunity to teach you a few things. This is specifically kind of an Algebra 2 level question, and so you're going to see a sneak preview of some things that you have yet to learn. So first of all, the equation in question is a quadratic function. And the shape of a quadratic function is, of course, a parabola. So it'll look something like this. However, the way that I drew it is incorrect. If I look at this leading coefficient here, it's negative. Call that the A value. This is the A, that's the B, that's the C. This A value is negative, and when your A value is negative, instead of having a parabola that opens upwards, this thing has to open downwards. So flip that thing over, rotate it. All right, anyway, so this parabola is supposed to intersect a line y is equal to c at exactly 1 point. So y equals c is a horizontal line. So for example, if it's y is equal to 5, it is a horizontal line specifically that goes through the y coordinate of 5. So if I take this line here and I make it intersect my parabola, the only way this horizontal line can hit at exactly 1 point is if it hits the vertex. So this horizontal line, is actually tangent to this curve. The word tangent means that it intersects at exactly 1 point, as we can see here. So this is a horizontal tangent line. And this is horizontal tangent lines in calculus are really important. If you do have an opportunity to take calculus, you'll see that. Now, of course, you don't need calculus to take the SAT. It's just basically up to Algebra 2, up to and including. So we should be able to use the tools that we already know in order to actually answer this question. So when I'm looking at this question, the most obvious answer, and the one that was selected by quite a few people, is this answer choice B. But I know, without even doing any work at all, that this answer should be the one that's eliminated first. And here's the reason why. If you take a look at the equation, which I'm just going to kind of rewrite here as y is equal to negative x squared plus 9x and then minus 100. If you were to let your x values equal 0, you're going to get the y-intercept. So if you let your x values equal 0, you have a y-intercept at x, not x, y is equal to negative 100. Well, what does that mean? It basically means that whenever you're drawing your little parabola here, you count down 100 spaces, let's say it's like right here, negative 100, that's where your parabola is supposed to touch the x-axis. Now, your vertex point on this thing is actually going to be a bit higher than that. I know this from experience dealing with some quadratic equations quite a bit. And so I would already know that if I were to draw myself a horizontal line through the negative 100, that it's going to hit it two places. That's called a secant line. So this is the reason why I would automatically cross out that answer choice B. And this is always to your advantage, of course, because originally, if you're just randomly guessing here, you'd have a 25% chance of getting the correct answer. But now that I've eliminated one of these answer choices, now I'm down to a third, so 33% chance just randomly guessing. Okay, so there is a very, very simple way to solve this problem, which involves the graphing calculator, and then there is probably the intended algebraic solution. I'm going to show you both of them. Okay, so realize that with the digital SAT, you now have access to the calculator for the full two math sections on that test. And it is, you do have an embedded copy of a test mode for decimals, which I'll show you right here. So here's the test mode. And you can actually in this app choose the assessment, and you'd go down to College Board where it says digital PSAT and SAT, and then start the practice. And this has some limited functionality. Apparently, I haven't found what it is because you can still put in equations like this. X plus Y is, let's say, equal to 5, and it'll still graph it in standard form for you. Wow. I think specifically what it does is that it will not allow you to get out of like the testing feature, like the testing app, which I think is Blue Book. Anyway, so I should be able to, actually, let me put these things side by side so that I can easily see what, see, that's one of the things that this thing does. You can't open another window right beside it. Okay, whatever. So I'll just have to flip back and forth. I guess I can handle that. So what I'm going to do is I'm just going to type this equation in. And then I'm going to type each one of these as y is equal to each one of those numbers. And just check to see which one of those hits my equation at exactly 1 point. All right, so first up, of course, is the original quadratic equation, which is y is equal to a negative x squared. You can see it's opening downward, just like we were talking about. And then a plus 9x, and then a minus 100. And you're going to see it's going to disappear. The reason why it's going to disappear is because that thing has been scooched down so far, so I need to zoom out so I can see that thing. So there we go. Now you can see right now, I'm going to put in y is equal to negative 100 in here. So y is equal to negative 100, and it's going to hit it at two places. You can see the vertex up here on my little graph. Actually, I can just tap it, and it tells me exactly where it is. Now, the difference here is that this is at negative, it's a decimal number, and all of my answers are fractions. So you could very, very easily just type in each one of those numbers and just see what the decimal number is supposed to be. So again, this is more evidence to suggest that the y equals negative 100 is the answer that I should eliminate first. So the next one was y is equal to, I believe it's negative 481 divided by 4. All right, and then you look at this and it's like, this is negative 120.25, so it's actually way down here. It's also touching it at two places. And again, we call that a secant line. So obviously that's not the answer. And then we also had y is equal to negative, I think it was like 319 divided by 4. Boom. Oh, well, look at that. It is exactly the one that we were looking for. You can see over here on the left-hand side, it even says that y is equal to negative 79.75, and it does hit my parabola at exactly 1 point at that vertex point. Okay, so that pretty much does the solution of this, but I'm going to actually go through this. That's answer choice C here. I'm going to go through this probably as they intend for you to answer it. I mean, if this is one of the last questions that are on the test, if all you had to do was just throw it into the graphing calculator, then it does make it a very easy question. So way back when, there were calculator active sections and calculator inactive sections. And this one, I think, is a much harder question if you had to do it by hand, if you didn't have access to the calculator. So I'm going to use this opportunity to teach you a few things about quadratics in general, and like how I can get this answer without relying upon Desmos as cheat codes. So here we go. It goes a little bit like this. Let's say that I have a general quadratic equation that ordinarily I would expect that the thing hits the x-axis in two different places, right? Or two x-intercepts. Well, we have ourselves a formula that tells us what those solutions are. And that formula is, of course, the quadratic formula, which is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Of course, you could probably sing that to Pop Goes the Weasel, and probably you have. Maybe entertained your family a little bit. Anyway, so this is two answers because of the plus and the minus here. Specifically, what I can say is that the one over here on the right-hand side, the x-intercept, is negative b plus the square root of b squared minus 4ac over 2a. And the one that's over here on the left-hand side, I'm going to say that this one is the other one, is negative b minus the square root of b squared minus 4ac over 2a. Now remember that what a parabola has is called symmetry. Specifically, it has an axis of symmetry that goes right through the vertex point and makes it so that if you reflect this parabola across this line of symmetry, it looks like you didn't do anything. That's what symmetry means. So in order to get exactly where this vertex point is algebraically, notice that it's just right in the middle in between these two numbers. Let's say that I had two numbers, two very, very simple numbers, like 7 and 9. And I wanted to find the number that is right in the middle between those two numbers. Obviously, it should be 8. But in order to find it, let's say, through arithmetic, essentially what you're doing is you're finding the average of those two numbers. So I add them and divide by 2. So 16 divided by 2 obviously is 8, and that's the number that we thought was right in the middle. Another way of thinking of this is taking 1/2 of their sum. It means the same thing as adding them and dividing by 2. And it's this kind of thing that I'm about to do to these two solutions to your quadratic equation. In other words, they're two x-intercepts. Why am I doing that? Because if I take the average between these two x-intercepts, I am going to get the x-coordinate of the vertex. So anything that's on that vertical line right there would have the same x-coordinate, and specifically it would go through the vertex, which is what I want. So let me show you that math. It's actually pretty easy. It looks hard, but it's actually pretty easy. So I'm going to take 1/2 and I'm going to add up these two solutions. So negative b plus the square root of b squared minus 4ac over 2a. And then add the other one, negative b minus the square root of b squared minus 4ac all over 2a. Yep. Okay, and then whenever I go to add two fractions, we know that we're supposed to keep the denominators the same, so they're going to stay as a 2a, and then you just add the tops. So when I add the tops, the negative b plus another negative b is going to make a negative 2b. So let me start writing some things down here. Take the half, it's a negative 2b, and then, hey, what happens? What happens to these two things, the square root there and the square root there? Notice that we're adding them. One's positive, one's negative. They cancel each other out. They eliminate, so they're gone. And that's why this thing actually turns out to be a little bit simpler than you might have thought. And then your denominator is supposed to stay the same, so 2a. Now the half that's on the inside, what I'm going to do is I'm just going to take half of that top number. So I cancel that out. Essentially, that's a 2 over a 2. And it reduces to a negative b over 2a. This is the x-coordinate of your vertex. It is also the equation of the axis of symmetry. Now, what's cool about this is that it's very easy to remember that it's negative b over 2a because it's right there in the quadratic formula. It's right here. It's x is equal to negative b over 2a. If you just remember that these two square root parts cancel each other out, what you have left over is the negative b over 2a. So let's take a look at our quadratic equation. Y is equal to negative x squared plus 9x minus 100 this is your A value, this is your B value. Actually, instead of A value, it should be the -1 that's there. And then here's your C value. So my X coordinate is going to be X is equal to -B, which is 9, over 2 times my A value, and my A value is -1. So when I simplify this, my two negatives cancel each other out, and I just get 9/2. All right, let's look back at the Desmos for just a second. If I look back at the Desmos, notice that that is, whenever I tap on that thing, 4.5. And 4.5 is the same thing as the fraction, of course, 9/2. Okay, and if I look back at my answer choices, notice that that's almost answer choice D, except for they threw in a negative. And maybe they did that just because like all of these things were negative and they're keeping it consistent, but at least numerically that matches up with that answer choice D that's there. Okay, now then, I don't want the X coordinate. I want actually the Y coordinate, because remember, it's supposed to be Y equals C. Y equals some sort of number. I want the Y coordinate of the vertex. So the Y coordinate of the vertex, how do I get that? Well, if I have the X coordinate, all I have to do is take it and plug it into this equation. So Y is equal to -9/2 squared, and notice where the parentheses are here. Only 9/2 is being squared, not the negative sign. Otherwise, they would have had parentheses around this, which would be silly because then there'd be no negative sign. Plus 9 times 9/2, and then minus 100. And of course, since you have access to a calculator, you could just type all of this stuff in here. However, I mean, if you had access to the graphing calculator, don't do all of this work. This is way too much work. You would just throw it into the graphing calculator as we did and find that line that hits your parabola at exactly 1 point. So what we're doing here is just, we're seeing how we could do it by hand if that's the way we were forced to do it. Anyway, so if I'm working this thing out by hand, I know you see these fractions, you're freaking out a little bit, but don't let them bug you. We can handle this as whenever I square a fraction, I'm going to square the top and the bottom. So I still have a negative. 9 squared is 81. The bottom squared is 4. And now whenever you multiply a whole number times a fraction, it only goes up top. The reason why is because this is as if it's 9/1, and you do top times top and bottom times bottom. That'll be 81/2, and then minus 100. All right, so since we have a couple of fractions in here, if I'm going to combine all of these things, I need a common denominator. So between the 4 and the 2, the common denominator is a 4. That's interesting. If I look at my answer choices, there were 2 of them that had a common denominator of a 4. Okay, so let's get them with a common denominator of 4. Y is equal to -81/4 stays. To get this 1/4, just double the top and the bottom. So 81 times 2 is 162/4. And then do the same thing on this one. Make this over 1, and then times 4 times 4. So it's 400/4, of course. Okay, and then I'm going to combine these two first. Well, remember that in order to get the 162, we doubled 81, and we're about to take 81 away from the 162, so that just ends up being 81/4 positive, and then we're subtracting 400/4. Okay, if this was exactly 80, I know that that would equal 320/4, but it's not. It's one more than that, so I need to take one more away from that number, and that's going to make that 319. And don't forget, you got to keep your negative sign there. And of course, that was the answer choice that we selected from the Desmos graph, 20 minutes ago. Now, look at this other answer choice. So we were able to see this one is the correct answer. This was the obvious incorrect answer. It was the same thing. It's the y-intercept that's there. This was almost the x value of the vertex. So where the heck did this answer come from? So let's go back down here to my work and notice that if I had messed up the signs on this, if this one was negative, these things would combine up to make a negative 481 over 4, and I think that's where they got that final answer choice. All right, so there you go. But like I said, I took this as an opportunity to teach you a little bit about some quadratic stuff, specifically about how you find the vertex of that quadratic if you ever needed it. But really, really, you're trying to work your way through this as quickly and painlessly as possible. So, graph, find your answer.